Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question, number 9 of 2017 NEET physics paper. So hence let us solve question number 9. It says the x and y coordinates of a particle at any time are this and this. So the x coordinate and y coordinate, suppose particle is here, its x coordinate is given by 5t minus 2t square and its y coordinate is given by 10t respectively. So the particle is here, suppose this is the origin and the particle is here, where x and y are in meters and t in seconds, so it is in SI system. The acceleration of the particle at time t equals to 2 seconds, so you have to find acceleration at the time t equals to 2 seconds. This is the question. When the particle is staying here with x coordinate and y coordinates, so as you change the value of t with time, the x position and the y position will change. So at time t equals to 0, the particle is at the origin because everything is 0. Now it starts moving with what acceleration is actually there, that way to find from here, because when you know x coordinate and y coordinate, we can differentiate that to get the velocity components. So if x is this, then the derivative of this is vx, x component will be dx over dt, and similarly vy will be dy over dt. So by differentiating this one we'll get the velocity, x component and y component velocities at any time t. Now because we are interested in acceleration, so we will differentiate again. If we differentiate again this, then we will get ax, which is dvx over dt, and here it will be ay, which is dvy over dt. So from here we will get the total acceleration, and the total acceleration is the acceleration, net acceleration will be ax square plus a y square under root. This is the net acceleration. So the particle is moving at any time it is here with x component and y component, something like that, then how the particle is moving in x direction and how it is moving in y direction, the speed at which, because it will be x direction and this is y direction, and differentiate this, we'll get how far, what rate it is moving in x direction and what rate it is moving in y direction. So first we'll find the velocity using these steps. So first I'll take x is equal to 5t minus 2t square. So what is given is x is equal to 5t minus 2t square. So if I differentiate this with respect to t, I'll get here 5 minus, this is for t. Okay, this is my vx. So this vx, if I consider this as the x, then vx is 5 minus 4t. And similarly, if I write y, which is 10t given, then differentiate this dy over dt, which is equal to vy, y component of this velocity. Suppose the velocity is in this direction, so x component, y component. So this is your v at any time t, and this is your vx, and this is your vy. So vy by differentiation we get 10. So vx and vy you got. Then how this velocity is changing with time, that will give the acceleration. So acceleration x component is dvx over dt. Vx already we got last time, it is 5 minus 4t. If I differentiate that, I will get minus 4. X is minus 4. Similarly, ay is dvy over dt, and vy I have got 10. so derivative of this is 0, so ay part is 0. So now a net, because our need is find net acceleration, so obviously the net acceleration is the square components and addition of this and taking the root. This is minus 4 the square, the magnitude, and 0 square, so it is 4 only meter per second square. 4 is the magnitude, but as far as direction is concerned, if you think, then this is minus 4 meter per second square. Only x component direction wise it is minus 4 meter per second square. With direction, this is the answer, because this part is 0. So if I choose that, then obviously I have minus 4. This is not per second square, this is actually meter per second square, meter per second square, meter per second square, because acceleration it is meter per second square. So 5 meter per second square or minus 4 meter per second square. The answer is minus 4 meter per second square. So option number 3 is the right answer to this question. Okay, thank you.